Hey guys, welcome to my channel. Welcome to another video on AI. So in this video, we are going to, go through a very latest news trend where, you must have heard that a model called or company called DeepSeek is making news. You will find every AI evangelist talking about it, AI enthusiast, talking about this on your LinkedIn profile or feed. We'll try to understand what the hype is all about. And since we are not maybe early adopters or early users of AI, we are coming from our data engineering background or the data background. We'll try to, connect the dots and why it is important and whether the news that they are making, whether that makes sense or not. So try to break it down. So let's look at their website. So the website goes by the name of deepseek.com. And I think this is a Chinese company. Let's maybe read few sentences here. DeepSeek achieves a significant breakthrough in inference speed over previous models. It tops the leaderboard among open source models and rivals the most advanced closed source models globally. So these are some of the benchmarks. So in language generation, they support English and Chinese. And on all the more benchmarks that are currently available, I think they rank, topmost in mostly benchmarks. For example, in language generation for English, they rank topmost in MMLU Redux. In MMLU, Llama ranks first. So these are all the benchmarks which are used to, judge whether the model that has been built is efficient or how efficient it is. And then based on code generation, I think most of the benchmarks they rank topmost in that. And then since uh, this model also has reasoning capabilities, that's why you have math in place as well. And for for math benchmarks, the top for almost all the benchmarks that are all out there. And for Chinese language generation, they rank topmost in CVAL, CEVAL, Simple QA. So maybe one of the reasons that they have become famous is because you know they are ranking in topmost categories, whereas all the benchmarks are concerned. So that could also be the reason. So you have DeepSeek V3, DeepSeek V2.5, Quen 2.5, Llama 3.1, Claude 3.5, GPT-4o. Maybe let's look at brief history of DeepSeek. History of DeepSeek and the founder. Is Chinese AI lab making waves in the world of large language models? Is a breakdown of his history and founder. Founder Liang Wenfeng, a billionaire and AI enthusiast who made his fortune in the hedge fund world. He co-founded Highflyer, a quantitative hedge fund, in 2016. Liang has also strong belief in power of AI. I think I have seen some of the interviews of Liang Wenfeng, so let me just Google his photo if I think who he is. Liang, a lot of names coming here. A lot of images coming here. No, I don't. Okay, this might be the CEO or the founder, but I don't think I have Seen his interview. So maybe I had some other person in my mind. But that's okay. History, early days 2016 to 2020, Liang being operating AI into high flash trading algorithms. So he comes from a trading background, so he might be developing certain things, models uh, in finance. Birth of DeepSeek. In 2023, High Flyer established an AI research lab focused on developing cutting-edge AI tools, spun off into its own company, DeepSeek. In May, with High Flyer as a major investor, DeepSeek quickly gained attention for its open-source approach and impressive LLMs. DeepSeek Coder, DeepSeek LLM, DeepSeek V2. So these are some of the models that they have released. DeepSeek Coder is the first one. Groundbreaking 671 billion parameter trained on massive datasets. Oh, activated parameters 671 billion parameters. That's a lot of parameters. And the closest to it is also the DeepSeek models in a configuration. You can see the second best is 236. Sorry, Llama is also close, 405 billion parameters. So which means, for these many parameters, you have to have a huge amount of data. So one of the other things which is, I think AI enthusiasts are liking about DeepSeek is because it's an open source. Some of the models such as GPT-4o and I think Claude 3.5 are closed source. What does it mean? Means that they would not expose their source code, or maybe they will not expose the architecture that they've used. For example, you can see here, since these are closed ones, they have not disclosed the architecture. Is Claude 3.5 a closed architecture? So maybe let us look at the definition of what are closed source LLMs. So maybe as the name suggests, closed source means uh, they don't facilitate anyone to look at their source code. Large language models where the underlying code and training data are not public, they are developed and controlled by private companies like OpenAI, Google, and Anthropic. And this is usually provided with through paid APIs or licensing agreements whereby a company might have a closed performance and optimization cons. Accessing these model often involves licensing fees or subscription. Okay, so if you want to use DeepSeek or Quen or Llama, you don't have to pay any licensing fee. You can just, use it. Just deploy or host it in wherever you want. So Google's Gemini is also closed source. Anthropic is closed source. OpenAI, although the name is OpenAI, the model is, closed source. Maybe the early models of OpenAI might have been open source, like GPT-3 or maybe before that. So let's see. Is GPT-3 open sourced model? We'll see. No, it's not an open property. It's also not an open source. So maybe they have just given the examples of latest OpenAI models. Okay, so that's what we know the difference between open source and closed source. So out of all these, benchmarks, I'm interested in knowing the architecture because since, I work as a lead architect, so I'm mostly interested in what is this MOE and dense architecture. What is MOE Architecture and Gen AI. The mixture of experts architecture is a powerful technique used in generative AI to improve the efficiency and capabilities of large language models. It's like having a team of specialized experts working together to solve a problem with their own unique skills. Experts and MOA mixture of experts consists of multiple smaller experts consisting. For example, in a language model, one expert might focus on grammar, another on factual knowledge, and another on creative writing. So maybe this is also based on agentic AI. So you'll have all of these agents or maybe so-called experts working autonomous, autonomously, and each of this will specialize in their own domain or task that is allocated to them, and then that's why it becomes more powerful. Gating network acts as traffic controller, deciding which expert, okay, combine the outputs from the selected experts are then combined to produce the final result. By activating only the necessary experts for each component, MOU models can significantly reduce computation cost compared to running a single massive model for every task. Allows for the creation of extremely large models with hundreds of billions or even trillions. As the workload is distributed among the experts, ML allows for the creation of extremely large models with hundreds of billions or even trillions of parameters. As the workload is distributed among, yeah, I didn't get this particular sentence or line. Maybe let's break it down. Please explain below sentence. So this is how we study, you guys, and I'm glad that I'm doing it with you. So if you're new to this channel, consider subscribing. Let's come back to the study. Let's break down the sentence to understand how mixture experts help scalability in large language models. This refers to the system of amounts of handling increased amounts of work or data effectively in the contextual, and it means building larger and more firms that can process more information and perform more complex tasks. LLMs are typically measured by the number of more parameters generally mean a greater capacity to learn represent complex patterns. However, training and running these really computationally expensive. This is easier training. So I think what they are saying here is since we have a concept of experts in these models, that's why they could be able to handle huge amount of data and remember guys we discussed that the larger the data is the larger the parameters. So let's return to this. MOE allows for the creation of extremely large models with hundreds of billions or even trillions as the workload is distributed. Okay, so since the workload is distributed, it's just like what you will have in big data. Since you have the distributed compute and storage, that means you can handle big data, and that is the reason why maybe if you have large models and if the workloads is distributed, it should be able to handle more data, which means it would have more parameters. Each expert can be trained on a specific domain, leading to improved performance and better handling of diverse inputs. Models can be easily updated and expanded by adding new experts. Examples of image generative mixture, GPT-4, there is diffusion, okay. Challenges of complexity, designing and training, okay. Okay. So maybe my next question would be, this sounds similar to, agentic AI. Then what's the difference between MOE and agentic AI? While both advanced and they operate at different levels, there is a breakdown mixture of experts. Is an architecture primarily focused on improving efficiency. It knows involves using multiple specialized network with a single model with a gating network focus aims to create autonomous AI that can independently make decisions to achieve goals, combining various languages. Model architecture, AI system design, purpose, efficiency, scalability, autonomy, goal-oriented multiple expert networks within a model, combination of LLMs, planning, primary focus on processing inputs and generating outputs, interact with environment, takes actions, and pursue goals. Decision making, limited decision making within the gating network capable of independently. So this somehow explains the difference between MOE and agentic AI. So MOE is mostly, part of your architecture, which is inside an LLM. Whereas agentic AI is once the LLM is available, how do you, design a system? And then obviously there are different purposes, mechanisms, interaction, decision making. So that makes some sense. The other architecture here was that was referred to here was dense. What is dense architecture pattern in Gen AI? In the context of particularly large and dense architecture refers to traditional model design where all parameters are connected to all others within a single. This is contrast to the model is divided into specialized subnetworks. Imagine a large conference room where everyone can talk to everyone directly. Group. This is more like having separate departments within each company. Oh, nice. This is very nice. Okay, got it. Difference between MOE and dense architecture patterns. The core difference, maybe, I'm just looking for a table here. This is also a nice thing in Gemini. I think this is also there in Perplexity, or this should be there in any of the, you know, LLM or Gen AI websites. Feature dense architecture and more all parameters interconnected. Processing entire network processes every input. Okay, less scalable, more scalable, efficiency can be. Okay, okay, that makes sense. That makes a ton of sense. Even though, we might not know what goes underneath within the networks, but this is good to understand. Dense net architecture, all the parameters are connected to each other. Whereas in MOE, parameters divided into expert networks. So you will have a sub networks. Within a sub network, maybe the parameters might be connected, but the sub networks might not be connected to each other. Or they would be. Yeah, they might not be connected to each other, and that is where the gating, technology comes into picture. that based on the input request, the gating algorithm will try to find out which subnetwork it has to use, and it will use that. Cool, that makes sense. Cool then. So I think we'll limit the discussion up till here. So the summary is DeepSeek is, gaining popularity because the computational cost is less. It's an open source, and they have performed well in most of the benchmarks. And their architecture is slightly different. Maybe they were the ones who, came up with this architecture. I'm not sure. So some of the things does make sense. So let me know how this, video went. I actually learned quite a bit, and I hope you would have also learned something. And if you want to watch similar videos, consider subscribing to this channel. We'll meet in the next video, guys. Till then, take care of yourself. Thank you.